Our last example for section 10.2, the goodness of fit test, again comes from OpenStax Introductory Statistics. Students in a social studies class hypothesize that the literacy rates across the world for every region are 82%. This is our null hypothesis, so H sub 0 will be that literacy rates in every region of the world is 82%. Mathematically, this means that since we have 10 regions, the proportion of literacy in every one region will be 10%, so that when you add them all together, you will end up with a total of 82% literacy rate in every one region. And the alternative hypothesis will be that the literacy rate in the regions is different from 82% across all of them. So it is not the same percentage of literacy in every region. So the table shows the actual literacy rates across the world broken down by region. There are 10 regions: developed regions, Commonwealth of Independent States, Northern Africa, Sub-Saharan Africa, Latin America and the Caribbean, Eastern Asia, Southern Asia, Southeastern Asia, Western Asia, and Oceania. And the literacy rates are shown. And we want to find the test statistic and degrees of freedom. We want to conduct a hypothesis test at the 5% significance level. Now, to avoid doing all of this by hand, I will go in Excel and do it. And I have entered here the regions and the literacy rates. And I don't need the probabilities to be 0.10. I know the expected number needs to be 82% in every region. So notice here that these are percentages, but they are written in percent. And therefore, as an expected number, I will assume that the units here are also percentages, but I will write them in percentages. And the totals are pretty similar. 820 is the expected and 817.8 is the actual. I have changed my formulas to include 10 rows of data instead of my previous tables had maybe 8 rows of data. So I have fixed everything. I don't need to base everything on the total here of 817.8. That was an approximation. It is supposed to be 820 if we think that all 10 of them should be at 82%. So observed minus expected will be the column E minus column G. And I can just copy down this formula. That squared will be column H squared. And again, I will copy that down. And then to find the Pearson residuals, I will divide the squared residual by the expected number, which was in column G, and copy that down. And the sum will be my chi-square test statistic. It happens to be 26.38. 9 degrees of freedom because I have 10 regions, minus 1 is 9. A p-value, which is a right tail chi-square test of 0.18%. And at the alpha significance level, this p-value is much smaller, indicating a very unlikely outcome if that outcome was coming from a theoretical distribution of every region having an 82% literacy level. So let's write the results here. I have a chi-squared test statistic equal to 26.38. I ended up with a p-value of 0.17% or 0.0017 when I rounded it to the 4 decimal digits. And for this reason, this is much smaller than alpha. My decision will be to reject the null hypothesis. And my conclusion will be that at the 5% significance level, the sample data provides sufficient evidence to support that literacy rates are not all the same at 82% in each region. So please, when you complete your notes for submission for our course, fill in the conclusion yourselves. Remember to mention only the alternative hypothesis in your conclusion. And also, you can try to see if you want to use the Art of Stat app for a chi-square test, which I didn't use, and also probably do this by hand to see if the results in Excel agree with what you just found, what we found, if your manual results and if the Art of Stat results agree with what we found in Excel.